Assalamu alaikum students. First MCQ is current electricity is that branch of physics which deals with charges in motion. So option A is correct here. A charge in motion is called, so here option A is correct. In metallic conductors, the current is due to the motion of option C, free electron. We know that in metals free electrons are present and that free electrons conduct the electricity in metal. So option C is correct here. The direction of conventional current is option A, opposite to the flow of electron. So here option A is correct. Okay. Let's suppose this is a battery and it's a positive terminal and this one is negative terminal of the battery. Okay. And some sort of bulb is connected here. So here we know that on negative terminal of the battery electrons are sufficient, and here on positive terminal the electrons are deficient here. Okay, so from negative terminal of the battery electron flows, okay, and then it comes to the positive terminal. So the direction of electron is from negative terminal to the positive terminal, but according to the conventional current, the current flows from positive terminal of the battery to the negative terminal of the battery. Okay, so look at the MCQs. The direction of conventional current is opposite to the flow of electron. Okay, look, the direction of electron is from negative to positive, but the conventional current direction is from positive to the negative. So here option A is correct. Fourth one, 20 coulomb of charge flows through a conductor for 2 seconds. The amount of current flow through a conductor is, now look at here, amount of current is equal to Q charge divided by time. Okay, so the charge is 20 coulomb and time is 2 seconds, so it will give 10 ampere. Okay, 20 divided by 2 will be equal to 10 ampere current. Okay, the amount of current will be 10 ampere. Fifth, the current flows through 2 meter long wire is 1 ampere. The charge flow in 1 hour is, so here we have to find the charge. Okay, we know that current is equal to Q divided by T and charge is equal to IT. Okay, here the current is 1 ampere and the time is 1 hour, so 1 hour is equal to 3600 seconds. Okay, so the charge is equal to 3600 coulomb. Here option A is correct. In thermocouples, the electricity generates from heat energy. In thermocouples, we know that one reservoir is hot and the other is cold. So due to that heat energy, the electricity is generated. A conductor is connected to a potential difference source of strength 24 volt and a current of 2 ampere flow in it. The resistance of a conductor. So here we know that V is equal to IR. The required is resistance. R is equal to V divided by I. Voltage is 24 and current is 2, so it will give 12 ohm resistance. Option B is correct. Which one of the following are ohmic material? So we know that metals are ohmic material. Option D is correct. The current voltage graph for thermistor is option B. Okay, this one is the C current voltage graph for thermistor. When the voltage increases, the current also increases sharply. Look at here, the slope is above and resistance decreases in this case. Okay, here we know that slope is equal to rise divided by run, I divided by V. Okay, and we also know that resistance is equal to V divided by I, and 1 over resistance is equal to I divided by V. Now comparing these two equations, we will get slope is equal to 1 over R. Okay, now look at here, when the slope increases, the resistance decreases. Okay, look, the slope is increasing and the resistance in this case decreases. Okay, this is the graph for thermistor. Look, this one is for ohmic conductor and this one is for filament bulb. Electrical resistance of material depend upon the dimension, temperature and the nature of material. Option C is correct. It do not depend upon the voltage, it do not depend upon the current. Okay, it only depend, resistance only depend upon dimension, temperature, nature of the material. Option C is correct here. We know that there are two formulas for resistance, like one is V is equal to IR and R is equal to V divided by I. But look at here, in this formula this resistance act as a constant of proportionality, okay? This one act as constant of proportionality. The formula for the resistance is L divided by A, okay? Resistivity, length divided by area. So in this case it depends upon the dimension, the nature of the material, and resistance also depend upon the temperature, okay? So option C is correct here. The resistivity of a material if area of cross section of material is double and the length is half, then the resistivity of material at constant temperature is. Now look at here, temperature is constant. This rho only depend upon the temperature and nature of material, okay? It depends upon temperature and nature of the material. Look here, the temperature is constant. It means that the rho will also remain constant, okay? This rho does not depend upon the dimension, okay? It do not depend upon the dimension, okay? So here option A is correct. The resistivity of a metallic conductor over a certain range of temperature varies. Now, when the temperature increases, then in that case the resistivity of metallic conductor increases. So here it is the direct relation, okay? Resistivity increases. While in case of semiconductor and insulator, it is inverse relation with temperature, okay? In case of metallic conductor, it is direct relation with temperature, while in case of semiconductor and insulator, the resistivity is inversely proportional with temperature. The conductivity of insulators and semiconductors over a certain range of temperature varies. Now look at here, this is conductivity. Now for insulator and semiconductor, what happens when the temperature increases? In that case the conductivity increases, okay? So direct relation with temperature. When we increases the temperature, so in that case the conductivity of insulator and semiconductor increases. And when we decrease the temperature, so conductivity also decreases. While in case of metallic conductor, okay? In case of metallic conductor, the conductivity has inverse proportion with temperature. In case of metallic conductor, when we increases the temperature, then in that case the conductivity decreases, okay? In that case it is inverse relation with temperature. The resistivity of material is 10 ohm meter. If the temperature drops by 2 centigrade, okay? Then the resistivity is dropped by 2 ohm meter. The temperature coefficient of resistivity of material is. Now look at here, the temperature coefficient of resistivity is alpha, which is equal to resistivity at temperature T minus original resistivity divided by original resistivity into change in temperature. Now look at here, in MCQ the original resistivity is 10 ohm meter, okay? And after, when the temperature is dropped by 2 centigrade, then the resistivity also dropped by 2 centigrade, 2 ohm meter, okay? The drop in resistivity means that it has been decreases from 10 to 8, okay? It is decreases from 10 ohm meter to 8 ohm meter. The drop in resistivity, 2 ohm meter drop in resistivity means that it is decreases from 10 ohm meter to 8 ohm meter, okay? Now the drop in temperature, the change in temperature is minus 2 centigrade, okay? The change in temperature is, now look at the MCQ. Look, the resistivity of material is 10 ohm meter, okay? The original resistivity is 10 ohm meter. If the temperature is dropped by 2 centigrade, okay? The temperature dropped by 2 centigrade means that, let's suppose the initial temperature is let's suppose 5 centigrade, okay? And the final is dropped by 2, okay? The final is dropped by 2, which means that it is 3 centigrade. The final is 3 centigrade, okay? Now here the change in temperature, we know that final minus initial. So drops by 2 centimeter means that it will be minus 2 centigrade, okay? Final minus initial means it will be minus 2 centigrade, okay? Now look, the resistivity is dropped by 2 ohm meter, so it means that it is decreases 2 ohm meter from 10, okay? Which means that 10 minus 2 will give 8. Okay, drops by 2 means that it is the final resistivity is now 8 ohm meter. Okay, now look at here, we have to convert this centigrade into Kelvin. Okay, now in order to convert this centigrade into Kelvin, so directly put change in temperature is equal to minus 2 Kelvin. Okay, now keep one thing in your mind, that the separation between the centigrade scale is equal to the separation between the Kelvin scale. Okay, so the change in temperature will be equal to, change in temperature for centigrade will be equal to the change in temperature for Kelvin. Okay, so these both will come same. Okay, so you don't have to convert this 8273 with this or something else. Okay, so directly put minus 2 centigrade is equal to minus 2 Kelvin. Okay, now look at here, we don't know what is the temperature. Okay, what was the original, final and initial temperature? It is just an example. Okay, you can also take this one is 10 degrees C. Okay, the initial is 10 degrees C and then it is dropped by 2 degrees C, so it will become 8. Okay, drop by 2 degrees C, it will become 8. Now the change in temperature will be final minus initial, so it will give minus 2 degrees C or minus 2 Kelvin. Okay, it is just an example, but here from the data the temperature is drops by 2 centigrade means that you will take it minus 2 centigrade. Okay, minus 2 Kelvin. Now look here, the change in temperature is minus 2 Kelvin. Now the final resistivity is the resistivity at T, or you can also call it as final resistivity at, and in original is minus 10. Okay, minus and original is 10. Now look at here, original resistivity is 10 divided by 10 and change in temperature is minus 2 Kelvin. Okay, minus 2, so here it will come minus 2 divided by minus 20 and the answer is 0.1 Kelvin. Okay, 0.1 Kelvin. Now look here, option C is correct. Okay, 0.1 per Kelvin, sorry, it is per Kelvin. Okay, the answer is 0.1 per Kelvin. Just correct it on your solution. Okay, it is 0.1 per Kelvin, per Kelvin. 1 mole is equal to, so it is per ohm. Okay, per ohm, it is the unit of conductivity. Okay, and we know that conductance, sorry, it is the unit of conductance. We know that conductance is inversely proportional to the resistance. Look, conductance, resistance. Okay, it is the reciprocal of resistance, so the unit is ohm. Okay, the unit of resistance is ohm, so it will become per ohm, so option C is correct here. 3 equal resistors connected in parallel have equivalent resistance R divided by 3. When they are connected in series, then the equivalent resistance is 3R. Okay, now look at here, 3 equal resistance. Okay, 3 equal resistance equal are connected in a parallel. Now for equal resistance, when one is R, R1, R2 and R3, and they have equal resistance which is equal to R. Okay, now for equal resistance, the formula for here in parallel, the formula is parallel R divided by N. Okay, where N is the number of resistance. Okay, the formula is R divided by N, while in series the formula is NR. Okay, where N is the number of resistance. Here 3 resistance, so 3R. Here option A is correct. What is the smallest total resistance which can be obtained by using only a 6 ohm resistor and 12 ohm resistor? Now there are 2 ways to obtain a total resistance. Okay, a total or equivalent resistance. Now the first method is series and the other is parallel. Now look at here, the required is the smallest total resistance. For smallest total resistance, they means parallel combination. Okay, in parallel combination we will get the smallest equivalent resistance. Now look at here, in parallel combination we says that the equivalent resistance, the value of equivalent resistance is smaller than the smallest individual one. Okay, keep this in your mind that the value of equivalent resistance is smaller than the smallest individual resistance. Okay, than the smallest individual resistance. Now look at here, the smallest is this 6 ohm. Okay, so the smaller total resistance will be smaller than this one. Okay, its value will be smaller than 6 ohm. Now look at here, the smaller is 4 ohm. Okay, the smaller equivalent resistance is 4 ohm. Look, 8 is also greater than 6. 6 is equal to 6, so this one is also incorrect. Okay, and 10 is also greater than 6. Only 4 ohm resistance is smaller than this smallest individual one. Okay, so this one was the shortcut method. Now if you want to calculate this one, so for calculation use this one formula, R1 multiply R2 divided by R1 plus R2. Okay, this is for parallel. Okay, and keep one thing in your mind, that this formula is valid only for 2 resistors. Okay, it is only valid for 2 resistors connected in parallel. Now look at here, 6 12s are 72 and divided by 12 plus 6, it will give 18. Okay, now on dividing these two you will get 4 ohm resistor. In parallel combination of resistors, look, in parallel combination voltage is same for resistance and the current is different. Okay, option C is correct. While in series the voltage varies and the current is constant. Okay, in parallel the voltage is same and current is different, while in series the voltage varies and current is constant. 3 resistors of 10 ohm, 20 ohm and 30 ohm are connected in series to a potential difference source of 60 volt. The current across 30 ohm resistor is. Now look at here, the 3 resistors are connected in series and we have to find the current across the 30 ohm resistance. Okay, now look at here, one resistance is 10 ohm, second is 20 and the third one is 30 ohm. We have to find the current in this one. Okay, and a 60 volt potential difference is given. Okay, first of all you have to find the equivalent resistance. Okay, the equivalent resistance. Now the equivalent resistance is R1 plus R2 plus R3. Look, these 3 resistance are different. Okay, that's why we are using this one formula. But in case of equal resistance, if these resistors would equal, now for that one we would find the resistance is RE is equal to NR. Okay, this one is formula, this formula is valid only for the equivalent resistance. Look, these resistance are different from each other. Okay, so we are using this one formula, R1 plus R2 plus R3. Now the equivalent resistance is 60 ohm. Now we have to find the current. Current is equal to V divided by R, 60 volt divided by 60 ohm. So it will give 1 ampere current. Now we know that in case of series combination, the current remains constant. Okay, the current in this one is 1 ampere and here it is also 1 ampere and here it is also 1 ampere. Okay, so we know that in series combination the current is constant while the voltage is different, but here the required is only current. Okay, so the simple is that you just find out the equivalent resistance and then find the current. Okay, on finding the current, that is 1 ampere, so it will be for the 3 resistance. Okay, so the current in 30 ohm resistance is 1 ampere. Look here, option A is correct. Okay, the current in 10 ohm, 20 ohm and 30 ohm will be same. Okay, and it is 1 ampere. A current of 9 ampere flows in a circuit of 3 resistors. Okay, and connected in parallel to a potential difference source. Look, the combination is parallel now. Okay, if each resistor has magnitude 5 ohm, then the current in third resistor is, look, the resistors has a same magnitude. Okay, now we have to find the current in the third resistor. Now look, here is the circuit. Okay, 3 resistors are connected in parallel, each of 5 ohm resistor. Okay, now there is certain potential difference V. Okay, and the current is 9 ampere here, and here the current is also 9 ampere. But in parallel combination, we know that the current is different. The current in the resistors are different from this one. Okay, the current in these 3 resistors are different from this one. Look, when the current come here, it will divide in these 3 arms. Okay, it will be divided in these 3 resistors, and from here again it will become 9 ampere current. Now look at here, the resistors are same. Okay, the resistors are same. It means that the current will be equally divided here. Okay, the current will divide equally in these 3 resistors. Okay, now look, the current is 9 ampere, so here it will divide in 3. By dividing 9 ampere into 3, you will get 3 ampere here, 3 ampere, and 3 ampere here. Now look, these 3 ampere is different from this one. Okay, that's why we says that in parallel combination, the current in resistance is different from this one current. Okay, now here the current is divided into 3 resistors, and look, the resistors are same. That's why the current will divided into 3. Okay, the current will be divided by 3. So the current in third resistor is 3 ampere. Look, it is first, second, and this one is third. Okay, so the current in third resistor is 3 ampere. The current is equally divided. So like 9 divided by 3 is equal to 3 ampere. Look here, option A, option B is correct. Sorry, option B is correct here. The birds sitting on an overhead transmission line suffering no harm effect, because here option A is their body have high resistance. This one is incorrect. Okay, their feet are very good insulator. This one is also incorrect. Look at the C option. There is negligible potential difference between their feet. This one is correct. Okay, because let's suppose we have a wire. Okay, and this one is high voltage wire, high voltage. Okay, and we have another wire, a low voltage wire. Okay, like in general we says that this one is hot wire and this one is cold. Like they are not actually hot and cold, they are high voltage wire and low voltage wire. Okay, now when a bird is sitting on this one, okay, let's suppose a bird is sitting on this one, so there is no potential difference. Okay, on this wire there is no potential difference. That's why there is no harm. Okay, now look at here, if a bird sit on this one, there is also no potential difference. Okay, so a bird is not harmed. Now let's suppose these wires are very close to each other. Okay, let's suppose these 2 wires are very close to each other, and a bird sit on both of them. Okay, like one foot is here and the other is here, so there will be a current flow. Okay, there will be a potential difference. The current will flow from high voltage to the low voltage through the bird's body. Okay, and it will get the electric shock. Now in MCQ, a bird is sitting on one transmission line, either it is on this one or on this one, so there is negligible potential difference between their feet. That's why here option C is correct. 4 bulbs of 10 watt, 20 watt, 30 and 40 are connected in series. The bulb that will shine more. Now look at here, in series combination, the brightness is inversely proportional to the power of the bulb. Okay, this one volt. So if the power is low, the brightness will be high. So here option A is correct. Look, in series combination. Okay, this one is valid for series combination only. 23. 4 bulb 10 watt, 20 watt, 30 and 40 are connected in parallel. Okay, parallel. The bulb that will shine more. Now for parallel combination, brightness is directly proportional to the power. Now when the power of bulb is high, the brightness will be high. Look, here option D is correct. Okay, this formula is valid for parallel combination. In parallel combination of resistor, the power dissipated depend upon the resistance of the resistor. The power dissipation is always dependent on the resistance, okay? Either it is parallel combination or it is series combination. The dissipation is always dependent on the resistance of the resistor. A current of 2 ampere flow in a resistor of 5 ohm magnitude connected in a series to a potential difference source. The power dissipated across the resistor is now, look at here, the current is given and the resistance is given. So the power dissipation is equal to I square R. Look, I is, to 2's are 4 multiplied by 5 is equal to 20 watt. Here option B is correct, okay? A source of 200 volt provided a current of 10 ampere to a house. The power delivered by the source is, now the voltage is given and the current. So power is equal to IB. The current is 10 multiplied by 200, so it will give 2000 watt. Option C is correct here. Electrical energy is expressed in the unit of kilowatt hour, okay? Electrical energy is always expressed in the unit of kilowatt hour. Look, we know that power is equal to energy divided by time. Now bring this time here, so it will be like this, okay? So energy is equal to kilowatt and hour. Like E is equal to, power unit is kilowatt into hour. So electrical energy unit is expressed in kilowatt hour. The electrical power dissipated in a resistor can be expressed as option A. This one is incorrect, okay? Let's see the other options. Look here, option B is also incorrect and C is also incorrect. Here option D is correct, okay? The power dissipation is equal to I square R, V square divided by R, or IV, okay? These are the formulas for power dissipation. A 12-watt battery when short circuited gives a current of 6 ampere. Internal resistance of battery is, now we know that the formula of resistance is V divided by I, okay? It's 12 divided by 6, so it will give 2 ohm internal resistance. An EMF source of strength 24 volt supply a current of 6 ampere to a resistor. If the internal resistance of a source is 1 ohm, then the terminal potential difference across the resistor. So EMF is given, current is given, internal resistance is given. We have to find the terminal potential difference. Look, we know that EMF is equal to terminal potential difference plus I, and R is the internal resistance. Now bring this IR on the other side of the equation. So it will become V is equal to EMF minus IR. So EMF is 24 volt minus current is 6 ampere and the internal resistance is 1 ohm. So 24 minus 6 will give 18 volt terminal potential difference, okay? So the answer is 18 volt. Here option B is correct. The maximum power delivered to a resistor is, look at here, it's a formula of maximum power delivered, EMF square divided by 4 resistance. Kirchhoff current law is also called law of conservation of charges, okay? In figure shown below, the current through the branch 5 is, now look at here, we have to find the current here. So according to the Kirchhoff current law, the amount of current entering, it will be equal to the amount of current leaving the junction, okay? So the amount of current entering is 5, 3 and 2, it's 10 ampere, okay? And here the one branch is 7 ampere, okay? And the other branch must be 3 ampere. So the amount of current entering is 10 ampere and the amount of current leaving is also 10 ampere. So here option B is correct. According to Kirchhoff voltage law, the sum of the potential changes across a closed circuit is, so option A here is 0, okay? The sum of voltage is equal to 0. That's why the Kirchhoff voltage law is also called law of conservation of energy. The resistance in 3 successive arms of a balanced Wheatstone bridge are, now 3 resistance are given, 10 ohm, 20 ohm and 30. The resistance in the 4th arm is, now the formula is R1 multiplied by R4 is equal to R2 multiply R3. Okay, this is the formula for Wheatstone bridge. You have to multiply first and last, first and fourth, and the second and third. Now the required is the fourth arm. Okay, R4 is required, so it will be R2 R3 divided by R1. Okay, now R2 and R3 is 20 multiplied 30, which is equal to 60 ohm and divided by 10. Sorry, 600 divided by 10, so it will give 60 ohm resistor. Okay, the fourth one is 60 ohm resistor. Look, this 2 multiply R2 multiply R3 will give 600 and divided by 10, so it will give 60 ohm resistor. Two resistors are connected as shown in the figure. The current in the circuit is now. In order to find the current, first of all you have to find the equivalent resistor. Okay, look, this is parallel combination. Okay, for parallel combination, in order to find the equivalent resistor, look here, the resistance are equal. Okay, the resistance are equal. So I told you that when the resistance are equal, then the formula for parallel combination is R equivalent is equal to R divided by N, where N is the number of resistance. So R is 6 divided by 2, so it will give 3. Okay, now the equivalent resistance for parallel combination is 3 ohm. Okay, so this is the formula when the resistance are equal and they are in parallel combination, so you have to use the formula R divided by N. Okay, so it will give 3 ohm resistance. Now you have to find the current. Look here, the voltage is 9 volt. Okay, 6 plus 3 is equal to 9 volt. Now the current, we know that V divided by R. Okay, like 9 divided by 3, it will give 3 ampere current. Okay, the current here is 3 ampere. Now look at here, the required is the current in the whole circuit. Okay, the current in the whole circuit is 3 ampere. But if it was like this, that to find the current in an individual resistor, okay, for individual resistors, then the current would be divided here and it will be 1.5. okay, like if the current in this one, only in this one will be 1.5. okay, because the current will equally divided here. Okay, the current would be equally divided here. But now the required is the current in the whole circuit. The current in the whole circuit is 3 ampere. Look here, option B is correct. In potentiometer, the ratio of EMFs of two cells is equal to. Now look, it's a formula E2 divided by E1 is equal to L2 divided by L1. Okay, potentiometer formula. So here option B is correct. 38. The EMF source of strength 10 volt gives balance point at 25 centimeter. The balance point on potentiometer for another EMF source of strength 20 volt. Now we have to find the balance point. Okay, now look at here, for potentiometer we know that E2 divided by E1 is equal to L2 divided by L1. So E1 and L1 is given and E2 is given. Okay, we have to find the L2. Now bring this L1 here on multiplication, so it will become like this. Okay, now put the value of E2, which is 20, E1 is 10 and L1 is 25. Now 10 ones are 10 and 10 twos are 20, so 2 multiplied 25 will give 50 centimeter. Okay, so the answer is 50 centimeter. The balance point for 20 volt source is 50 centimeter. 39. Slide wire bridges and post office box work on the principle of Wheatstone bridge. So this one was the last MCQ of current electricity. If you have any problem in any MCQ, then write in the comment section. Allah Hafiz.